Today I'm going to be talking to you about Chapter 9 in the Power of Critical Thinking, Edition 7, Dr. Lewis Vaughn's book. And we're going to talk about inductive reasoning. And this particular chapter is very dense. It has a lot of information in it, and so I'm thinking this is going to be a pretty long video. So settle in, know that you can always come back and watch whatever piece you're on next. I may end up breaking this chapter into more parts than just one, but for now, one is good, and we'll see how we go on that. We're going to talk about enumerative induction, analogical induction, and causal arguments today. I'm going to walk through the agenda here. And just so you know, this is another one of those chapters where they've broken up the exercises. They're at the end of each of these kind of ABC sections. So kind of keep that in mind. Chapter 9, the first part is about enumerative induction. And this is where we kind of look at opinion polls and survey questions and that kind of stuff. And exercises 9.1 through 9.5 are at the end of that. Analogical induction, analogies, their properties, relevant similarities, diversity of cases, and the review notes are kind of listed there. Analogical induction has just 2 exercises, but they have lots of possibilities in them. And then causal arguments, we're going to talk about what they are, how to classify them, some stuff from John Stuart Mill's methods, why we get confused when things are not really causal, but we might think they might be. And then, again, another run at necessary and sufficient conditions there at the end. And these are exercises 9.8 through 9.10. So that'll help us get along. The first and best thing we need to know is that we like deductive reasoning because it's very defined and you get a right answer. It's like arithmetic, okay? 2 plus 2 is always 4, okay? In deductive reasoning, things are true or false. And if we line them up correctly and we can look at them through truth tables or through Venn diagrams, we have our answer, right? It's definitive, it's conclusive, and that's what a deductive argument is. Inductive argument is probability, okay? It's not a less than, it's not a failed type like we've talked about before. Inductive reasoning is really where we live all the time, right? It's the land of partial credit and extra credit and, fill in the blanks. And the sentence here, this crucial sentence on page 301, it's at the bottom of the second paragraph there. It says, inductive reasoning, though, in contrast to deductive reasoning, gives us most of what we know about the empirical workings of the world, allowing us in science and in ordinary experience to soar reliably from what we know to what we don't. We're making predictions. We're saying, okay, we know enough about this particular thing, whatever the thing is, to say, okay, it's probably going to do this. It's probably going to act this way. It's probably going to have this result. And anytime, of course, that we put human beings in the stir around pot here, it's going to be hard to predict exactly what's going to happen. We may know all the pieces parts and how they work and that they work. And then we put them all in a room together and everything falls apart. It's difficult to make really accurate predictions about human behavior. Now, we know certain things happen in a certain way, okay? How do we know that? Because we've seen it numerous times, okay? What happens when? Okay, well, normally, we work on different probabilities there. Enumerative induction, okay, and I am on page 301. Enumerative induction is more about what we can observe and what we can understand through observation, and then what kinds of things can we then know based on those observations. And in enumerative induction, we're looking at and we're going to have a lot of vocabulary. Not as much as, say, chapter 5 or 6, whatever, but a bit. Enumerative induction is going to take this form. X% of the observed members of group A have property P. Okay, this is what we absolutely know for true. So, therefore, X% of all members of group A probably have property P. And there's some things that go into making these two statements closer and closer together. Okay, one of those is what we call, okay, our target population. All the members of the group. We want to know how this group A is going to react to a particular, say, a particular new show. Okay, so the target population, say, we're looking at adults in the United States. Okay, we're talking close to 200,000 people here. That's a huge number, right? So we can't talk to all of them. Okay, not if we use a few lifetimes, but we can pick a group, the observed members, and that's our sample. Okay, these are the observed members. Now, if we, the big we, are someone like the Pew Research Group or Gallup or Nielsen, these are companies that have been doing surveys for, in the case of Gallup, since the early 1900s. Okay, they've had a lot of practice. Okay, and we think about experts. You know what we call an expert. They are expert opinion polls makers, doers, whatever. Their sample population, if they're trying to figure out, okay, so how do the American people feel about this particular TV show? Okay, well, we're not going to talk to everybody because we can't, but we are going to poll a target population. Sorry, can't do the whole target population. We're going to do a sample population. So these observed members, okay, and there's a couple of things that we have to do. One is, okay, when we're looking at these things, we have to make sure that we know what the relevant property is. Okay, so we want to know what they're going to say about this particular TV show, okay? And this is, the relevant property is the property under observation. Now, if I want to know what folks in the United States think about this particular show, can I just poll my students and say, hey, what do you guys think about the Umbrella Academy? Okay, do I get a viable result where I can say, okay, so 75% of my students say they love this particular show, so that means 75% of America will love this show too? Well, probably not, okay, because we have to think about all the things that are relevant to our target population regarding this particular property. Okay, so now we're talking about something very wide and open, right? If you have a subscription to Netflix, you can watch it. Okay, well, that also kind of takes things down a bit. But anyway, the relevant property, we also have to think about all of the relevant properties in the target group for this particular property. Okay, so there are things that won't make any difference, right? Hair color, eye color. What are you wearing today? Those are things that, while they would set people apart, aren't really relevant to their picking a particular television show, right? And we have to think about, okay, what's the makeup of adults in America? Okay, what percentage of them are we going to talk about socioeconomic? Are we going to talk about class? Are we going to talk about race? Are we going to talk about gender? All kinds of things we could filter. But we have to make sure that our filters are meaningful, purposeful. And that's not always the case when we look at a lot of things that people claim are true. Okay? So when we're looking at the property in question, okay, the relevant property, we need to make sure that anything that would affect that is part of our filter. Okay? So in the case of this television show, okay, I believe the only way you can get it is if you subscribe to Netflix. Okay, so how many folks in the country subscribe to Netflix? Well, that's one of my filters, right? If you can't watch the show, period, why do I care about your opinion? Okay, so it's not a matter of discrimination here, it's a matter of being discriminating. Okay, figuring out what relevant properties in the target group are particular to this survey. Okay, and remember that an inductive argument not only can be strong or weak. Okay, it has a good format, all the bases are covered, but it can also vary in its strength. Okay, it can be strong because it has a lot of support for its answer. Okay. Now, the book walks through some very good examples. Okay. And when we look at page 303, we find out that there are ways that the sample group can be not representative of the target group. Like we were saying earlier, if you have a sample that doesn't match the target population in these relevant ways, your survey answers are going to be way off. Okay, it happens to even the best of pollsters. So those of us who are just kind of practicing a little bit may not get very good answers, but we can still play. When we're talking about target population, sample population, all of those pieces, you have some, and I didn't go far enough yet to get there. At the end on page 312, we have some pieces there. Okay, so when we're talking about strong versus weak, okay, strong means we're actually answering the question we've asked. Some of you found that out on tests, right? You can write a beautiful answer and still get 0 points because you didn't answer the actual question. In this case as well, you can have problems with your sample if it's not representative of the group and if it doesn't understand what the questions are. Okay, so you get these weird answers. Okay. I like this little quote in the margin on 303 by Henry Mayhew. The deductive method is the mode of using the knowledge, and the inductive method is the mode of acquiring it. Okay. And of course, you can have all of this stuff go right, but your premises are false. And then you have a failed argument. Okay, 2 things. I think it's 2 things anyway. Yes. 2 things that you have to keep in mind when you're looking at opinion polls or enumerative induction in general is sample size. We've had this vocabulary word a couple of times already, hasty generalization. We're guilty of hasty generalization whenever we draw a conclusion about a target group based on an inadequate sample size. So what's adequate? Okay, is it 10%? Is it 1%? Actually, the number isn't as important as whether the sample size is enough to tell us about the target group. Okay, and so the percentage doesn't matter, really. And in fact, the book walks through this kind of, you can make it more and more You can make your sample size larger and larger. Past a certain point, it doesn't really help us much, okay, to get the pieces. If you're going to make it huge, you might as well ask everybody, and then you don't have a sample, you have just the target group. There's a whole list of all kinds of things there on page 304. But you need to know that in general, the larger the sample, the more likely it is to reliably reflect the nature of the larger group, okay? This is true. The more folks you add to your opinion poll, the more likely you are to get a good answer, right? Get a correlative answer. And this is the big thing. It's the very bottom. It's in italics at the bottom of 304. The more homogeneous a target group is in traits relevant to the property in question, the smaller the sample can be. The less homogeneous, the larger the sample should be, okay? So if our target population is very much alike to each other, okay? All the pieces in this target group are very, very similar, okay? Then our sample size can be small, and we still get a right answer. We still get a correlative answer. That's what homogeneous is, right? More the same. If our group is very diverse and different from each other, and they have a lot of traits in common, but they also have a lot of things that they're not in common with, then we need a bigger sample size just to make sure we touched all our bases. Okay, that's kind of common sense, right? People in general are too diverse to judge a large target group by just a few of its members. Even though biologically, DNA-wise, we are all very similar, within a couple points of each other, really. Emotionally, psychologically, all those other fun things that we do for people, we are all very, very different. And in fact, people from the same family can be very different in their opinions and in what they do. So, okay. To be truly representative, this is page 306. To be truly representative, the sample must be like the target group by 1, having all the same relevant characteristics, and 2, having them in the same proportions that the target group does. Okay? So, if I'm going to ask my students even a question about something here at JCC, okay? I have to be careful because I have to look at what is the kind of demographic makeup of folks who come to JCC versus what is the demographic makeup of the folks in my room, okay? Every year when I used to teach this as a seated course, we would look around the room and go, yeah, no. So average age for college students here is 27. Some of you are lots younger than that. Some of you might be older than that. That's how it works. There are, the last ones I heard, we were over 60% female. So we have to think about what that looks like in a classroom before we would do an opinion. Okay, bottom of 306, opinion polls. Inductive arguments, opinion polls should be strong, have true premises. More precisely, any opinion poll worth believing must, 1, use a large enough sample that accurately represents the target population in all the relevant population features, and generate accurate data, in that the results must correctly reflect what they purport to be about. And you think, well, duh, but it's amazing how many times that's not true. Okay. Now, we've talked about, okay, the sample population. How do we get it? Okay, if we want our particular survey, our particular opinion poll to be as correct as possible, and by correct we mean it's going to reflect the attitudes and answers of the whole with just a few folks, we have to make sure our sample population is random. And by random, we mean that every person or every item in that group has an equal chance of making it into the sample. Not too horrible, right? That's a problem sometimes, though, because as humans, we like to make patterns out of things. And it's really, really hard for us on our own to choose to be random. Okay, now you may have friends that you're like, no, they can pull that off, and that's fine. But there are ways to make sure that your sample is more random than not. One of those is using a computer-generated random number generator, and it does the work of figuring out, okay, how many of those folks do we need to take? And you can set filters, and you can do all kinds of fun things. It still, because humans made it, it still has a hard time being absolutely random, okay? Case in point, think about the shuffle on whatever music player you like. Yes, it shuffles, but it's built to not exactly be random. It will hardly ever, well, I guess it depends upon how new your sampler is. My very ancient at this point MP3 player will never play the same song back to back. But if it were truly random, that would happen occasionally, because every time we reset it. Okay. Now, shuffle isn't exactly random, right? It's go through all these songs once in a different order than what I put them on there. Not exactly random, but random is hard. Okay. We have to do our best to be as random as possible so that we get everything from the target population. Okay. Now, we can mess up our sample in lots of ways. One of those is what we call a self-selecting sample. I have to slow down to say that because all those S's. But the big deal here is that things that ask us as members of a certain thing to give our opinion. Okay. Now, in some ways, it works. In other ways, not so much. If we're going to make a conclusion that is the American population wants X, okay, we can't allow our sample to be non-random, and we can't allow it to be self-selecting. Self-selecting surveys are very much like student evaluations of a class at the end of the semester. I've been doing this for 27 years, and every semester we get these, student evaluations. And in the past, they were bubble things, right? Everybody sat in class, you filled them out, you turned them in, we're good. Well, now we have only online stuff. And last semester, for example, in the spring, I taught 70 students this humanities class, okay, critical thinking. And out of 70 students total, I got 7 who actually did the student evaluations at the end. So 1% of my students turned in, bothered to do the survey. Okay. Well, in one class that was 2 people, in the other class that was 3 people, in another class that was another 2 people. How representative can that be? Well, not very, because in all 3 classes, I had one person who was not happy with the class at all. And then the rest of the folks were very happy with the class. So, and that's what you usually get when a self-selecting sample. You get polar opposites. You get folks who are like, yes, 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 this is the greatest thing since sliced bread. And then the other one that says, you should never let this girl teach again. So it happens that way with any self-selecting sample. Usually you get folks that are very strong and passionate in their views, and it's not a good estimate of how everybody feels. Okay, so we have a couple other pieces here that I'm going to kind of pop back and look at these boxes. On page 307 and 308, there's a further thought box that says it's about how survey questions go wrong. And pay attention to this because it's going to be important for the test, but it's also important for kind of daily life stuff. You can, in any situation, do leading questions, things that lead people to answer a particular way, whether they feel that way or not, and then you have troubles. Okay, when you do things like that, when you order your questions in such a way that people already have a negative view of something, and then you ask them how they feel about that, they're going to say negative. Same thing with question phrasing. You can phrase questions in such a way that people 9 times out of 10 will choose to answer the way you want them to. Okay? And we have to be careful about that. The other part is our false dilemma idea, fallacy from back whenever, where we restrict their choices. And if you want to be able to say, this is the best show since, I don't know, Happy Days or whatever, then you have your answer, right? You can push that out there. That's not being honest, and that's not being fair. Oh, the other thing that you have to watch out for is a lot of times these polls will tell you things about percentages, but they don't tell you how many people they polled, and they might not give you a straight answer just by knowing these numbers. A mean is an average, right? Add them all up, divide by the number of things you just added up, and you have an average, okay? Your grade point average, for instance, all the grades you've had so far divided by the number of credits, there's your GPA. The median, and this is always one of those things that cracks me up about realtors and different places that are like, oh yeah, come here, this is a great place to live, our cost of living is lower, our median house prices are $100,000. Okay, well, it's more than I have, but we have the idea that, okay, that's the middle of the road, that's the average. No, that's the middle of all the house prices that we have. Makes no difference in the average. It doesn't give you a very clear idea of what the cost of living is like in this particular area, only that there's an equal number of houses above that amount and below that amount. Okay? And then the last one is mode. Now, I don't see that used very often in statistics because it doesn't really tell you a whole lot other than the mode is the most common value. Okay? And he gives us a string of numbers there that have 3 number 13s. That's the mode. Even though the lowest number is 7 and the highest number is 30. Okay, 13 is there in the middle, so kind of interesting. Okay, onward. Okay, a couple of things about when you get a survey, say you have this one, let's see, is 64% and TV no is 22%. 86% said had an opinion. Okay, so 14% of the population said eh. But then we get this idea, plus or minus 6. In this case, our plus or minus 6 doesn't make a difference. Okay, TV yes still wins. Now, think about the last time you watched the results come in from some sort of election, political election. Sometimes you'll get this. You'll have Jones has 48% and Smith has 42%. Okay, that's a pretty good margin there, right? But it's also plus or minus 6. These could be the same number. Okay, I have a 6% plus or minus. Sorry, guys there. So if I take 6 off of this one, I get 42. If I add 6 to this one, I get 48. So this is still too close to call. That's why you get frustrated there at the end, because it's like, what do you mean it's too close to call? Look at the margin of error. Okay? And that is the range that this particular number could be based on what we know about the target population. Okay? So plus or minus 6 isn't horrible. A lot of times when you get a Gallup poll or a Harris poll, sometimes it'll be as low as plus or minus 2. Okay? But for the most part, plus or minus 6 is not bad. And you think about where that goes here. You have to be careful and pay attention that you don't fall into the trap of, well, Jones has definitely won. Because maybe not. And if you remember back to 2016, that's a big deal for a presidential election. So we have to keep in mind our margin of error gives us the range within which we are confident of our answer. Okay. Now, the other part of this is our confidence level. It's kind of looking at it from the other way. So if my confidence level, if I want my confidence level to be high, okay, say 90%, then I'm going to have a rather large sample so that my margin of error is less than 10%. I want it to be 90, right? So we have to be careful when we see percentages and things given to us on television or online or whatever, that we look for this little plus and minus, do a little bit of math. And if they publish it, look for the confidence level. They don't always publish it. Sometimes you have to kind of dig down for it online, but the confidence level in this case would be 94%, because we're plus or minus 6. That's a really high confidence level, because maybe we've got, we know we're going to have 100% of the precincts in, and that's going to tell us. Right now, we have to see. So, and then on page 312, you have your official definitions for target group, sample, relevant property, all the way down to confidence level. And then you have exercises to do. Okay, analogies. I'm going to erase some of this. An analogy, and you know this from probably 8th grade. 8th grade? Maybe younger than that. But anyway, similes and metaphors. Okay, figures of speech. Similes and metaphors are things that are using analogy. Okay, an analogy is a comparison of 2 or more things alike in specific instances, respects. Okay, and when we're using analogy or analogical induction, and I'm on page 317, you have a little bit of wiggle room here. Okay, let's see if that'll hold my throat for a little bit longer. Okay, so an argument by analogy compares at least 2 things on a variety of levels, okay? And analogical induction has a pattern, just like everybody else, right? So it says thing A has properties P1, P2, P3, plus property P4. Thing B has properties P1, P2, and P3. Therefore, thing B probably has property P4. Okay, P for property. That's all we got right now. So, thing A has properties P1, P2, P3, and this other one, P4. Thing B, as opposed to thing 1 and thing 2, has properties P1, P2, P3. So thing B probably has P4 as well. Wow, I can't remember the crap today. Okay. That sounds pretty normal, right? We have this idea here that there are things that are very similar, and so they're probably similar in this other thing too. Not too hard, right? And so there are ways for this to go off the rails. If our P1, P2, and P3 are not relevant to P4, then we can't make the analogy. Okay, like I was saying before, when we're talking about a sample group versus a target group, if my sample group does not match my target group in the ways that matter to what I'm looking at, then I'll get wrong answers all the time. Okay, so this is an analogy, is things are alike in certain ways, and so they're probably alike in this other way as well. Okay, we have to be careful. Remember, because it's an induction, it's not absolute. Okay, it is very much probabilities, right? All of induction is probabilities. Some of them are very close to being absolute, but not quite. Okay, we can't account for every single variable or every single instance, so we have to say probable. And there are some really good examples here on 318 and 319. There's a little box here, further thought on analogical induction in moral reasoning. And we're going to spend most of chapter 12 on that idea. So, but when we try to show that a particular action is right or wrong, a lot of times what we do is we compare it to other actions that we already know are right or wrong. Okay, and so that's kind of the fun part there. On page 320, we get our kind of marching orders here. We have things that we're talking about in analogical induction that can make it more likely to be true. Okay, that's evidence, right? Something that makes our premise more likely to be true. And so if we pay attention to these attributes and kind of parse them out correctly, our answer will be even more correct than if we didn't. Okay, and it matters. So we have relevant similarities. Okay, the more relevant similarities there are between the things being compared, the more probable the conclusion. Okay, so again, we're talking about these things. Okay, if these are relevant similarities, relevant similarities are items that both have in common, all have in common that matter to our argument. Okay, so if I'm trying to say that these two animals are very similar, okay, they have a lot of DNA in common, they both are mammals, which means they give birth to live young, they nurse their young, they have a dense coat of fur, they have a very similar skeletal configuration, and thing A has what we call a prehensile tail. Okay, it means it can use its tail consciously to do stuff for it. When we think about gibbons, monkeys of a certain kind, they can move themselves about, right? Their tails or their stabilizers, whatever, but they can do it consciously. It's not something that they, just kind of hanging out there. Even cats, okay? Now, they can't use their tails very much to, help them move around, but they are a very good indicator of their emotions, huh? But anyway, so these relevant similarities. So my thing A has a prehensile tail, okay? Now, I will tell you, that is a fairly rare occurrence in the animal kingdom, prehensile tail, okay? So thing B has all those things that I mentioned before in common with thing A. So it probably has a prehensile tail as well. Well, what do we know? Okay, are those similarities relevant to the tail thing? Well, we did mention DNA. Okay, we did mention, okay, they're a class of mammal. They have very similar DNA, and these other things are true too. Okay, is that enough? Okay, well, we'll find out here in a little bit. The other thing we have to think about is relevant dissimilarities. Ways in which our two things are different that might play into this idea of a prehensile tail. Okay, what is it? Well, okay, they can walk upright. Almost all of the mammals who have prehensile tails, even though a lot of them will choose to use all four limbs to walk, they can very easily stand up and walk. Okay, 2 feet, like us, bipedal. And I'm going to tell you, thing A is, thing B is not. Thing B always has to walk on all fours. Well, that's something that's relevant in the dissimilarities and takes the possibility that thing B has a prehensile tail down a notch. Okay, this is a relevant dissimilarity. Okay, now the next piece that will help us is the number of instances or cases that show these relevant similarities, the stronger the agreement. Okay, so, sorry, I lost it. Number of instances. Okay, right now I only have 2. And I'm comparing them to each other. So my number of instances is not very high. It's only 2, right? 1 of each. Now, if I could say, okay, thing C has properties 1, 2, and 3 as well. It also has a prehensile tail. Oh, well, maybe that helps thing B have a little better chance. So, okay. And then the other one, the last one, is diversity of or among cases. Okay, how many different things can we say are the same here? So if I add my C, it's the same, and it has prehensile tail. I add D, it's the same, it has prehensile tail. That makes thing B more likely to be true. Okay, the greater the diversity among the cases that exhibit the relative similarities, the stronger the argument. Okay, we need to be careful when we're talking about diversity that we're talking about natural diversity and not something that we've assumed is diverse. Okay, observed diversity. So if I'm looking at these things, they're all mammals. Okay, that takes our diversity down just a little. But this is, I have a bovine, I have a canine, I have a feline, maybe I have, I just lost the other one I was going to think about. Anyway, I have them from different classes of species. Woohoo! I have better diversity, better chance that thing B has a prehensile tail. Okay? At the bottom of 322, you have Analogical Induction review notes. Okay, 322. And then we have exercises for the analogy section. So, not too horrible. Last set is causal. Now, I will tell you, causal arguments are pretty rare when they work all the way through. And they also have a bit of a problem because we tend to mess them up. Okay, a causal claim or a causal argument is an inductive argument that has a causal claim, X caused Z. Okay? And I'll have you some other things. Remember that they can only give us probable conclusions because they are still inductive. And, excuse me, this probability can be problematic for causal arguments. Okay, so one of the things that we have to think about is knowing that probable cause has to follow a certain way of thinking, but also a certain way of being. And so we have a couple of things here on page 326, 327. We're trying to find the best explanation for a phenomenon, or for a state of affairs, or for an action, okay? And so we're going to spend a whole chapter on this idea of inference to the best explanation, okay? And it's okay. It goes through a few things. One of the best way to test for causes is things that John Stuart Mill, we've talked about him before, came up with these causal arguments and formulated them into what are now known as Mill's methods. Okay, we like alliteration there, Mill's methods. And so there are different pieces here. And at the bottom of 327, there's kind of a, here's what happens when we have an argument based on the method of agreement. My apologies, my ear is itching to death today. Anyway, agreement, yes, Mill's methods. So when I'm looking at stuff, Mill's methods, we have agreement. Basically, says that if two or more occurrences of a phenomenon have only one relevant factor in common, that factor must be the cause. Okay? This is basically weed them all out. Okay? And then we have one that is difference. Basically, on 328, says that the relevant factor present when a phenomenon occurs and absent when the phenomenon does not occur likely is the cause. Now, this doesn't sound a whole lot of difference there, right? This is basically when C is present, X occurs. This is when C is absent, X doesn't occur. Okay. Now, a lot of the times we do A and D, agreement and difference, and both of those work. Okay. The other part of his that he does is correlation. I always have to think about how to spell that. Correlation. Basically, the amount of C present correlates. I don't know how to say that otherwise. to the amount or degree amount. Yes, I'm good today. I really am. Okay, so it's this graph, right? If I have a nice little box here, and this is 0, and this is 100, and this is 100, correlation says the more my input goes up, so does the output, okay? So they run together parallel. And we can test that as well, because if a little bit is good and a lot is better, then correlation works, okay? But it's not always a safe way to go. Correlation doesn't always mean that it's a causal thing. Sometimes it's just that these two things went walking together. They don't cause each other. But the more instances we have of this, the closer we can say, yes, this is a correlation. The further thought, is it causal confusion or ESP? It's very interesting. The idea of paranormal stuff, Dr. Vaughn is not all that thrilled about, but lots of people believe it. So there's a piece there. I want to look at causal confusions on 332. Things that we identify as cause, but we are incorrect. Okay, so we think about, remember that no inductive procedure can guarantee the truth of the conclusion. That's deductive, right? That's deductive. Causal confusions are very easy to come by, and they happen all the time. Sometimes we misidentify relevant factors, okay? We assume sometimes that because X happens before Y, that X causes Y, but that's not always the case. Most of the time, it's because we don't understand, we don't have enough background information to understand how this particular item works, okay? So we have to think about all the relevant factors that are in there, as far as only those things that could possibly be causally connected to the occurrence of the phenomenon being studied. So we have this idea that just because something happens before something else, and actually that's going to come a little bit later as well. Lack of background knowledge might lead you to dismiss or ignore relevant factors, or to assume that irrelevant factors must play a role. And really, the only cure for that is to dig deeper, study more, find out. Mishandling multiple factors. We just don't look hard enough for possible causes. We miss relevant factors because we don't know enough about the topic or the instances that we're looking at to tell for sure. We get misled by coincidence, and we think there must be a causal connection there. I caused the television to go bad, so that kind of stuff. Don't assume that a causal connection exists unless you have a good reason for doing so. And causal is hard, like I said before. Very often we want to say something proves when we just want to, when really all we're able to say is that it shows it's probably true. Okay. Confusing cause with temporal order. This is the other piece. We believe that a cause must precede its effect, but just because one event precedes the other doesn't mean that the other one, the earlier event, caused the other. Sometimes yes, but not always. And sometimes things happen in such a way, or we observe them in such a way, that we confuse the cause with the effect. Now you think that's kind of crazy, and how can you do that? Well, does your coffee drinking cause you to feel stressed out, or do your feelings of being stressed out cause you to drink coffee? Good luck with that. I like that. Don't assume that a causal connection exists unless you have good reason for doing so. Say that over and over again. Okay. On 337, there is a very important newsmaker's box. Okay. Now, I have dear friends who will go down this road, and it doesn't matter that I can show them, 100 different studies, literally, that say this is not true. They believe wholeheartedly that childhood vaccines cause autism. And this is wrong. Straight and simple, it's wrong. There was a particular very unscientific study that has been disproved, again, 100 times. But because it's out there, still out there, people still believe it. So anyway. And this is an ongoing problem with lots of things in our country, is that people want to believe what they want to believe, that whole availability error. And it's hard for folks in general, it's hard for folks to give up their incorrectness. We hate to be wrong. Yeah, we hate to be wrong. And so even though there is a huge body of evidence that vaccines and autism do not have a causal connection, there are lots of folks who still hold tight to that. And really no amount of science is going to prove to them that they're wrong. And so they go on their merry way. The last little piece here in this chapter is necessary and sufficient conditions. We talked about this briefly, I believe, in like chapter 2. But the book here goes into a few pages of definitions and how we get things going and all of that. So a necessary condition for the occurrence of an event is one without which the event cannot occur. Okay? The sufficient condition for the occurrence of an event is one that guarantees that the event occurs. Now, sometimes they are the same thing, but not always. So we're trying to figure things out here, and on page 340, they put out this. There are some ways to tell. The use of the word if by itself signals the use of the word if by itself signals a sufficient condition. If sufficient condition is what's meant, then the statement says that UN's refusing to act will automatically trigger the troop deployment. A little example there. The idea of necessary condition is expressed by the phrase only if before the stipulated condition. Okay? And then conditions that are both necessary and sufficient are indicated by the phrase if and only if. Get that a lot of math. So keep that in mind. And then you have the last of the exercises, 8, 9, and 10. So I know that's a lot, and this is long, and I hope that you've stuck with me here and you've gotten to the end of this. Chapter 9 is very important for the rest of our book study. It sets up kind of the conditions for inductive argument and how that works. And so take your time with this, make sure that you practice a lot and that you have all the pieces kind of put together. If you have questions, you know how to get a hold of me, you have my email. So have a great day.